Hello Bobcats. Today we're going to talk about bond polarity. Now, bond polarity can be determined from the difference in electronegativities of two elements involved in a covalent bond. Let me rewrite that in a covalent bond. Okay. So let's see what I'm talking about. Let's take a carbon-oxygen bond. So if I look at carbon and oxygen, and I take the electronegativity chart for carbon and oxygen, we see that carbon has an electronegativity value of 2.5. Oxygen has an electronegativity value of 3.5. So I have a 2.5 value for carbon and a 3.5 value for oxygen. Now the difference of that, and it's an absolute value, would be a 1.0. So we'd say that this is a polar bond, meaning that there's an unequal share of electrons between the carbon and the oxygen. Now let's make a chart of knowing when something is nonpolar covalent, polar covalent, and ionic. So if the differences are less than 0.4, then this is a non-polar covalent bond. If it is 0.4 to 1.7, if it's in between those values, then it is a polar covalent bond. Now, polar covalent, the greater the difference, the more polar the bond will be. In other words, the greater difference in partial negative and partial positive charges. And then if it's greater than 1.7, then it is an ionic bond. So we have nonpolar covalent, polar covalent, and ionic. And in this case, it was 1, which is between 0.4 and 1.7, so it's a polar covalent bond. Now we also have different ways of indicating the what is partial positive and partial negative in a polar bond. So let's again look at this carbon-oxygen bond, and here we have, because this carbon has a lower electronegativity, it's going to have a partial positive charge. And because the oxygen has a higher electronegativity, it's going to have an unequal share of a higher unequal share of the electrons. It's going to be a partial negative charge. Now, again, let's go back over here and say, make it that in a polar bond, the electrons are unequally shared. With higher electronegativity values having a higher share or a greater share of the electrons. Now, this symbol right here, this delta, which is lowercase delta in the Greek alphabet, represents partially charged. Means that something is partially charged, not a full charge, but partially charged. And then we're going to draw what's called a vector, a dipole vector, and the dipole vector dipole for short, the dipole vector shows the direction of the unequal sharing. In other words, if I take this dipole vector and I draw it so that the arrow points towards the more electronegative element, or the one that has the partial negative charge, this will indicate that the dipole direction. So, and it's easy to remember that we put a little positive sign on the element that's partially positive and the arrow towards the element that's negative, and it's a dipole vector. And another thing is that the size of the vector or of arrow indicates the magnitude of difference. Of polarity, let's say, of polarity. Okay, so if there's a greater difference or higher polarity of the bond, then the arrow will be longer. So let's practice some of these. I'm going to put this in a box up here so we know that this is a chart for us to look at whenever we need to know when something is polar, covalent, nonpolar, covalent, and ionic. Okay, so let's take a hydrogen carbon or carbon hydrogen bond. So if I take carbon and hydrogen, now I go back to my electronegativity chart. Carbon is a 2.5 value and hydrogen has a 2.1 value. So we have a 2.5 for carbon, a 2.1 for hydrogen. So that difference is 0.4. Now remember, anything 0.4 and greater is going to be polar covalent. So this would be a polar bond. And we can indicate where the negative and positive part of it is. We know that this is a higher electronegativity, so it's going to have the partial negative value, lower electronegativity, partial positive value, and we would draw the arrow from the hydrogen, because it's partially positive, towards the carbon. And I'm going to draw a small arrow because this is a very low polarity or difference here. Let's look at sulfur and oxygen. So if I take a sulfur oxygen bond, again I look back and I have sulfur is a 2.5, oxygen is a 3.5 on my polarity. So I have a 2.5 for the sulfur and a 3.5 for the oxygen. That difference is going to be 1.0. Again, I go back up to my chart and it's in between 0.4 and 1.7, so it's a polar bond. And I'm going to indicate where the polarity occurs. And so in this case, this is a low electronegativity, so the partially positive charge will be on the sulfur and the partially negative charge will be on the oxygen. And I would draw my dipole vector from the sulfur to the oxygen, and it would be a much longer arrow because it's a greater polarity than this is. Now, so we're going to do a couple more real quick. Let's look at carbon and sulfur. So carbon we have already figured out is a 2.5, sulfur is 2.5, and so that is 0. So this is a, again, below 0.4 is a nonpolar covalent bond. So this is a nonpolar bond. Okay, so there's 3 examples where you have nonpolar, polar, and a much greater polar bond than this one here. And the last one we're going to look at is, let's just look at an ionic bond to make sure we understand it. So if I take calcium bonded to chlorine, and I look at my calcium and chlorine, calcium is a 1.0, chlorine is a 3.0, so we have a 1.0, 3.0. That difference is a 2.0, which is greater than 1.7, so this is an ionic bond. And with that ionic bond, we would say that this is positive and this is negative. Not partial positive or partial negative. It is a true positive and a true negative value in an ionic bond. So that is bond polarity. And our next topic will be polar molecules. And I'll see you next time.